Hi, this is Calvin Cox. It is Thursday morning at 4:49 a.m. and it's October 17, the year 2013. Now, this is a re-recording because I forgot something last night when I recorded what I'm going to talk about that was ultra critical, and so I completely forgot that aspect of it, and I thought, well, I better redo this again because it wouldn't be quite fair if I don't. And the question is, why does matter accept a dent? I'm going to rephrase it, and then you'll be able to look at the other way I'm looking at it. So I'm going to look at it two ways. And let me take my reagent. Let me take this, and I'm going to dent something and show you what I'm talking about. Let me get up in the camera. Okay, if you take this piece of board, okay, and I'm going to take this and I'm going to rub it right here. Make a dent. Okay, now if you look at that dent stays there, okay? And that's the whole basis. Two ways of looking at that. Okay, there's two ways of looking at this. Why does it accept the dent? And why doesn't the dent come back out? Okay? It's one of those things you don't think about. It's kind of like the apple falling on the head of the guy who started the whole concept of gravity. You know, why? Geez. If certain things always accept a dent, I guess you assume, well, they just accept a dent. Maybe you're not really thinking about it. And so I have a take on this. I have a theory on it. I could be wrong, but I have an equal chance of being right. So my theory is that at the center of the atom, where the proton is and the electrons wants to come in, that there's antiparticles holding the first one or two shell electrons out. Okay? And those antiparticles are like an arm, me being positive, this being the electron. The antiparticle is the arm, and so the electron wants to come in, but it's stopped by the arm, so it kind of goes this way. My theory is that why this accepts a dent in the first place is because the magnetic forces, you can see these magnets right here, okay? This would be, for instance, before something's dented. And then when something is dented and crushed, watch this, okay? See how it will change, it will move. And it stays the same. I can hold this way, that way. It doesn't move. Let's say it's crushed a lot more. It would move even more. Okay? Let's move it even more. Okay? So you can imagine millions of these particles. That millions or 10 millions or billions or whatever of these particles, all in the antiparticle sections being crushed and changing their shape a little bit. Okay? That's why it accepts the dent in the first place. Okay? That's part of it. Now, the other part is, why doesn't the dent come back out? Okay? It's kind of two it's two parts. Why didn't it come back out? Okay, well, the center part will take the shape because the shift in the, well, this is also called like crystalline structure. This would be called that the atoms have I've read a lot, crystalline structure. Okay, what the hell is a crystal? In the classical idea of an electron orbiting a proton center, like the moon orbits the earth or the earth orbits the sun, okay, I don't buy that. I think it's a bit different. I think it's more like the idea that there is antiparticles holding the electrons away. Actually, I don't believe that they do orbit. Okay, maybe the very outer shell electron moves and interacts and loops around with other atoms. But what I'm trying to say is that you could clearly see how this shifted position and it held in the same place where you turned it around. Let me do that again, because I'm not on the other side of the camera. I'm not sure how this is coming out. These are two simple bar magnets that I bought at the hardware store. And you can see that if you apply some force, it'll slip and it moves to a place and it basically stays there. So that could explain why, you know, that dent actually does stay in the piece. Okay, or you could look at it, why is it dentable? Okay. Now that would also raise another question, why are some things very easy to dent and other things not? For instance, a piece of rosewood, a piece of ebony, or a piece of hard maple, if you take your thumbnail and try and, you know, leave a mark in those, they're very difficult to do that. Okay, some of them are basically impossible with your fingernail to leave a mark in it. But other wood like pine, it's a lot easier. I'm not sure exactly the reason for that. Or even regular maple, it's easier to leave a mark in it. So, all right. Now I'm going to cover the part, why doesn't a dent come out? Because I guess I'm trying to disprove the classical idea of the electron orbiting like you know, the moon orbiting the Earth. I'm trying to get rid of that idea of that theory, because my idea is, if that theory were correct, when you dented something, for instance, this would be the proton center and the electrons orbiting. If you dented something, you would leave kind of like an indentation. But if things actually did work in that classical sense where they orbited, eventually that orbit should straighten out. Okay? You would push something in, the orbits would be occurring, they would naturally want to come back to a normal position, and so the dent should basically come back out. Excuse me. So, but that's not what I believe it is. I believe it's more like this: positive center, antiparticles holding the electrons away from coming in to the middle, and then that would be the first and second shells, and then the third, fourth, and on shells would be simply likes repel. Okay, like if you have a bunch of static particles or pieces of styrofoam or anything that can accept a static charge, and if you hold it in some sort of insulated situation where the charge will not immediately dissipate, what you'll see is that the charged particles that all have the same charge will repel each other. Okay, that's what I think is happening from the second shell on out to the very last, is those particles of like charge are repelling each other. Okay, so I believe the dent occurs and holds because the antiparticles are shifted, like I moved the magnet. And I believe the classical idea of the electrons orbiting is not correct. Otherwise, the orbits would normalize back to what they were, and the dent would come out. Okay, so to put the this in perspective, why doesn't a dent in a material smooth out and eventually disappear after electron orbits normalize? The reason I believe is because they don't orbit. Okay, they're like this model with the antiparticles. And so when you dent something, it shifts the antiparticles, okay, and then they hold that new shape. Anyway, that's my take on it. Thanks.